We most frequently encounter photographs on a screen connected to the internet, without considering the history embedded in every image that the retina fleetingly receives. When we view an image of a sunlit subject on our mobile telephone, the electric light that forms that image is only nanoseconds old, but the depicted sunlight appears to us as the result of a process beginning some 200,000 years before. Starting with the formation of photons in the sun's core, this process ends with them streaming from the surface of the sun, travelling 8 minutes to reach Earth. Some photons find their way to reflect off an object. Some of these then find their way into the lens of a camera. The winter sun punched through the window. There was no significant interaction with the atoms that occupied the glass. Uninterrupted, the waves hurtled through the eye of the camera and crashed onto a silicon shore. The sensor screamed, R255, G255, B255. Around the periphery, several thousand photons refracted. A liquid crystal display, LCD for short, is a flat panel display or other electronically modulated optical device that uses the light modulating properties of liquid crystals combined with polarizers. It was dusk. The air was cold, and I had been waiting for the bus for 15 minutes. The sun was setting behind the tenements. As it rounded the corner at the end of the street, the raindrops on the shelter window switched on and formed a liquid screen, buzzing with diffracted light. I basked momentarily in its glow. The drops began to disperse, and the screen revealed an image of the street beyond. The light faded. I continued to wait for the bus. All day, every day, the sun hurls a steady stream of photons toward the Earth in the form of high-energy, shortwave radiation. Some photons are reflected by atmospheric particles, clouds, snow and ice, even ocean whitecaps. Other photons are absorbed by the Earth's land and ocean surfaces, which heat up. These heated surfaces emit photons back to the atmosphere in the form of lower-energy, long-wavelength radiation. Some of these photons eventually make it all the way back out to space. The balance of incoming and outgoing photons over the whole planet, the net radiative flux, determines Earth's temperature's set point. The physicist said, "It is a fundamental physical rule that it's impossible to distinguish one photon from another." The physicist said, "The order they arrive in is of no significance, and it is totally and fundamentally impossible to say where a photon came from." The physicist said, "Since photons travel at the speed of light, then the whole concept of time and age doesn't mean anything. Light does not have memory." An image of a tabular iceberg was shared by NASA's social media in 2018. It was widely shared across popular science and culture websites, due in part, no doubt, to its disarming appearance. The National Geographic's editorial described its 90-degree angles, flat surface, and almost perfect rectangular form as a satisfying image of order in a world besieged by climate change-induced chaos. The giant slab of ice acts as a mirror reflecting photons back to space. What would it mean to read this rectangular light reflector as we would a photograph? Can we imagine it as a screen broadcasting an image of itself extraterrestrially as its surface bounces photons back to space? An image of climate change on Earth, only possible to view from a spacecraft or alien telescope.